Okay, this is a video on distance and midpoints. Okay, so we're going to start with distance. Okay? So if I ask you to find the distance on a number line, all you have to do is subtract the two coordinates and take the absolute value of them. Okay? If I ask you to find the distance on a coordinate plane, we're going to use the distance formula, which is right here. So we'll do one example of each of them right now. Okay? So example one, use the number line to find CD. Okay? Now, if you want, you can just count 1, 2, 3, 4, 5, 6. But if this was a really big number line, you're probably not going to do that, right? So let's use the formula above. Okay? You want to find CD. You want to find the length of CD. So we're going to write down CD equals, no bar above it, remember. And we're going to do the absolute value. You're going to subtract one from the other. Now, it does not matter which one you start with, because the distance from C to D is the same as the distance from D to C. So it does not matter which one you start with. I'll start with D. So I'm going to say CD equals, and I'm going to do 1 minus negative 5. And that's going to be in the absolute value symbols. Okay? Minus a negative is plus a positive. So CD equals the absolute value of 1 plus 5, which is the absolute value of 6. The absolute value of a number is how far away the number is from 0, and it's always positive. So the absolute value of 6 is 6. Okay? If I said the absolute value of 7, that's 7. The absolute value of 20 is 20. The absolute value of negative 5 is 5. The absolute value of negative 18 is 18. The absolute value of negative 100 is 100. The absolute value is always positive. So the answer for that one is 6. Example 2, find the distance between R and S. Now, one way to do this is to use the Pythagorean theorem. You could label this segment, however long that is. You could label this segment, however long that is, and use the Pythagorean theorem to find the missing side. Or you could use the distance formula. Now, that's where the Pythagorean theorem comes from. So distance formula is above. I'm just going to recopy that down here. Okay, so it's x2 minus x1, that's squared, plus y2 minus y1 squared. Now what you want to do is you want to label, I would label ahead of time what's x1 and what's x2. Now it does not matter what you call x1. Okay, you could call 5x1, or you could call negative 3x1. I'm just going to call 5x1. Okay? It doesn't matter which one you start with, okay? The distance from R to S is the same as the distance from S to R. So I'm going to call the 5x1. If I call the 5x1, the number right next to it has to be y1, okay? x1 has to be next to y1. That's important. That matters, okay? x1 has to be next to y1. So again, this has to be x2 because I called that x1. x2 has to be next to y2. So now let's substitute into the formula. x2 minus x1 means negative 3 minus 5. Just substituting. Okay, negative 3 minus 5. All I'm doing is I'm substituting into the formula. Plus y2 minus y1. y2 minus y1. So negative 3 minus 1. Okay. And now let's do the subtraction, order of operations. Negative 3 minus 5 is negative 8. Negative 3 minus 1, that's negative 4. Now be careful. Okay. Negative 8 squared means negative 8 times negative 8. That's positive 64. Negative 4 squared means negative 4 times negative 4. That's positive 16. Add those together and you get the square root of 80. Okay. Now this is going to be a little tricky. You have to simplify that like you did in Algebra 1. Okay. So let me go over here and do this. Okay. You have to simplify that with perfect square numbers. Okay. What are perfect square numbers? 1 is a perfect square. So this is, let me do this. This is like a little side note. Okay. 1 is a perfect square number because it equals 1 times 1. 4 is a perfect square number because it equals 2 times 2. Okay. 9 is a perfect square number because it equals 3 times 3. 16 is a perfect square number because it equals 4 times 4. I'm going to keep going. 25 is 5 times 5. 36 is 6 times 6. 49 is 7 times 7. 64 is 8 times 8, and so on. I'm going to stop there because that's good enough for now. To simplify the square root of 80, you have to figure out, are any of these numbers factors of 80? Are any of these numbers factors of 80? And if so, choose the biggest one. Okay? So 1 is a factor of 80. You can ignore 1 because that's kind of meaningless for now. 4 is a factor of 80 because 4 times 20 is 80. 9 is not a factor of 80. 16 is a factor of 80 because 16 times 5 equals 80. 25 is not a factor of 80. 36 is not. 49 is not. 64 is not. So 16 is the biggest number on this list of numbers. That's a factor of 80. And 16 times 5 equals 80. So I'm going to rewrite the square root of 80 as square root of 16 times square root of 5. Okay? And then I'm going to simplify the square root of 16 because the square root of 16 is 4. So this is the final answer. This is the distance between R and S. Okay? The distance between R and S is 4 square root of 5. Because of the way the question is worded, you can circle that if you want. But the distance between R and S is RS. So I'm going to say RS equals 4 square root of 5. And that's my answer. Okay. Let's move on to the next page. Okay. This definition is midpoint. Okay. The midpoint of a segment is the point halfway between the endpoints of the segments. Okay. If X is the midpoint of a segment, meaning if X is halfway in between the segment, then you can say that AX, the first half, equals XB, the second half. Okay. Let me draw that really quick for you right here. Okay, to explain that. I drew segment XB segment AB right there. Okay. If X is the midpoint of that segment, so if X is halfway in the middle, if X is exactly in the middle, then it means that this half equals this half. In other words, they're congruent. So AX equals XB. In other words, segment AX is congruent to segment XB. Okay. Now this right here, this is the midpoint formula. Let me copy that down for example 3. Okay, so here, this is the formula that we're going to use. The formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So find the coordinates of M, which is the midpoint of segment PQ. And that's P, and that's Q. So you have to find the midpoint of this segment. So I'm going to label ahead of time. I'll label that x1. If that's x1, the number right next to it has to be y1. I'll call this x2. I'll call that y2. x2 has to be next to y2. And now I'm going to substitute. So it says the midpoint is represented by M. So I'm just going to say M. You always divide by 2. Always divide by 2. Always divide by 2. And the formula says add the x's. So -1 plus 6. And add the y's. So 2 plus 1. So now -1 plus 6 is 5 divided by 2. 2 plus 1 is 3 divided by 2. You can leave your answer like that. That's the midpoint. If this was like 10 over 2, you could make that 5. You know, if this was 8 over 2, you could make that 4. But we can just leave the answers like this. That's the midpoint. Okay, now this next one is tricky. This time, E is the midpoint. So you're given the midpoint, and you're given one endpoint. You have to find the other endpoint. Okay, so this one's tricky. So here's what we're going to do. Let's ignore all the y's and let's focus on the x's. Okay, I'm just looking at the x's. I don't care about the y's. We'll do that in a minute. Let's look at just the x's. Okay, E is the midpoint. E is the midpoint. Okay, it tells you that. That midpoint x value is -6. -6 has to equal, I'm going to call it x1 plus that x value. Okay, so the midpoint is E. The midpoint's x value has to equal the missing x value plus the given x value divided by 2. Solve that for x1. So what you're going to do is you're going to multiply each side by 2. It gives you -12 equals x1 plus -5. Okay? And then you're going to get x by itself, so you're going to add +5 to each side, and you get -7 equals x1. Okay, so we're done with half the problem right there. That's half the problem done. Okay. Now let's move on to the y's. Okay, let's focus on just the y's. This is the midpoint. Take that value. The y value of the midpoint is 4. It's going to equal the missing endpoint that we want to solve for, plus the given endpoint that we have for y is -3. And again, we're going to divide by 2. So you take your midpoint y, which in this case is 4. It equals the missing y plus the endpoint y of -3 divided by 2. Solve that for y1. So multiply each side by 2, and you get 8. Now add 3 to each side, and you get y1 equals 11. So these are the coordinates of our missing endpoint. Okay, that was D. So D equals -7, 11. If you want to check your answer, take your two endpoints, F and D. -7 plus -5 is -12, right? Divided by 2 equals -6. Take the y values. 11 plus -3 equals 8. Divided by 2 gives you 4. Okay, that one was tricky. This is a good one. Now, example 5. What is the measure of segment BC if B is the midpoint of segment AC? So if B is the midpoint, it means that this half is congruent to this half. So these are equal. So set them equal to each other. So you don't have to write this out, but AB is congruent to BC. That means that the measures are equal. So AB equals BC. So 4x minus 5 equals 11 plus 2x. Solve that for x, bring all the x's to one side, subtract 2x on each side. 2x minus 5 equals 11. Add 5 to each side, 2x equals 16. And then that gives you x equals 8. Now you have to actually find what BC is. So let's do that over here. BC equals 11 plus 2x. And you know x is 8, so BC equals 11 plus 2 times 8. So 11 plus 16. Again, when you say a segment equals a number and has a certain length or a certain measure, you do not put the bar above BC. So just BC like that equals 27. You know what? So let's take 1 second and check over our answer, okay? If we just got that BC is 27, then this should also be 27. AB should also be 27 because it's a midpoint, so they should be equal. So let's just check that. 4 times x, 4 times 8 is 32. Minus 5 is 27. So, yeah, that works. That's how you can check over your answer. Okay, and then we're just going to end with one definition right here. It goes over what we talked about a little bit earlier, but a blank is any segment, line, or plane that intersects a segment at its midpoint. That is called a segment bisector. Segment bisector. So in the diagram below, you see how segment AB is cut in half? Because this half has 1 tick mark, and this half has 1 tick mark. So that means that this half, AM, is congruent to MB. Okay? So since it's cut in half, whatever is cutting it in half is called a segment bisector. So in this example, segment CD is a segment bisector of AB. Or line CD is a bisector of AB. So whenever a segment is cut in half into 2 congruent halves, whatever is cutting the segment in half is called a segment bisector. Okay? So that's the end of this lesson, midpoints and distance.